Next, Fourier transform of derivative of a function. So result 2. Next result, the Fourier transform of nth derivative of f over n of x is equal to minus ip power n f bar of p. F bar of p is the Fourier transform of f of x, provided the condition is n minus 1th derivative of f of x is 0 as x tends to plus or minus infinite. That is, f n minus 1 of x, limit x tends to plus or minus infinite, f n minus 1 of x is equal to 0. So in notation, Fourier transform of nth derivative of f, which is equal to minus ip power n f bar of p, provided limit x tends to plus or minus infinity, f n minus 1 of x is equal to 0. We know Fourier transform of f of x is f bar of p, which is equal to 1 by root 2 pi integral minus infinite to plus infinite f of x e power ipx dx. That is the equation number 1. So now Fourier transform of nth derivative of f, that is equal to f n bar of p, which is equal to 1 by root 2 pi integral minus infinite to plus infinite nth derivative of f e power ipx dx. That is the equation number 2. Which is equal to 1 by root 2 pi integral minus infinite to plus infinite e power ipx derivative of n minus 1th derivative of x. So we will get the nth derivative when you take the derivation of n minus 1th derivative, right? First derivative dy by dx, second one derivative of first one, right? So d by dx of dy by dx, that is d square by dx square. Now derivative of second one is third one, right? Similarly, derivative of n minus 1 is, you will get nth derivative, right? So using uv formula, that is integral u dv, which is equal to uv minus integral v du. Here u is equal to e power ipx and v is equal to f n minus 1 of x. So 1 by root 2 pi uv e power ipx n minus 1th derivative of x, lower limit minus infinite, upper limit plus infinite, minus integral v du, integral minus infinite to plus infinite. V is n minus 1th derivative of f, and then derivative of e power ipx, right? Ip into e power ipx dx, right? So we know the given condition is limit x tends to plus or minus infinite, f n minus 1 of x is equal to 0. So whenever you are putting upper limit infinite and lower limit minus infinite, n minus 1 of f, that is f power n minus 1 of x tends to 0. So first term becomes 0 using the condition whenever we are putting upper limit and lower limit, right? So first term 0, so 1 by root 2 pi into 0 minus integral minus infinite to plus infinite f n minus 1 of x ip e power ipx dx. Taking ip outside, minus is already there, minus ip by root 2 pi integral minus infinite to plus infinite n minus 1th derivative of x e power ipx dx. So proceeding like this after n minus 1th time of integration by parts, right? So take f n minus 1th derivative can be written as derivative of n minus 2 the derivative of f power n minus 2 derivative of f power n minus 2 into x, right? Proceeding like this, right? You will get after n minus 1th time you will get minus ip power n, right? Because first time when you are having n, first time you are having minus ip starting from this zeroth term, right? 0th point. But after 0, if 0th point you are having minus ip power 1. So after n minus 1 time you are having minus ip n power n, right? So by root 2 pi integral minus infinite to plus infinite f of x e power ipx dx. So that is equal to minus ip power n f bar of p, which is to be proved.